when you have a set of numbers, and you can see they follow a pattern, and they follow a pattern of multiplication or division, then we call that geometric sequence. And the division one can be written as multiplication, that's why we group those together. We call these geometric sequences. So this set of numbers, if you notice, you can see here that this one, I'm multiplying each number by 3 to get the next number in the pattern. Okay, so what we call 3, call this R, or the common ratio. Okay, so when you see R is the common ratio for a geometric sequence. Now you can always get R if you're looking at a bunch of numbers. If you take one of the numbers, one of the terms, so we call this 18, and we divide it by the term preceding it, so 6. So 18 divided by 6, you get 3. Okay, and so you can do that also with any of the terms. You take a term and divide it by the number preceding it. So you can see this will follow with this same pattern down here, the second set of sequence, the second pattern here, right? So if I take 8 and I divide it by the preceding term, you're going to get a negative 1/2, and that is the common ratio for this pattern. The other thing you need to know in order to use the formulas that you're giving is understand what these things mean. So remember, just like in arithmetic, the first term, we write that as a sub 1. So the first term value, this a sub 1 represents the value of the first term. So in the second sequence it's 32, and the first one it's 2. Okay? Now if I said a sub 5, that means what is the value of the fifth term, or the fifth number in the pattern. So we can see 1, 2, 3, 4, 5. In this second term it's 2. And up above, 1, 2, 3, 4, 5, it's 162. Okay, so the little number down here represents the term number. And when you see it written as a sub a number, that says what is the value of that term. Okay, so you can use this formula. Usually you're just going to use this first formula here, which is a sub n equals a sub m times r to the n minus m power. Okay, so remember these are term n and m are term numbers, and a sub n and a sub m represent the value of those terms, numbers. R is your common ratio. This formula is given, but it's pretty much the same thing except for you're replacing this a sub m with the first term, which then makes m1. Okay, so you really just need to kind of know this formula right here. You're going to want to put that down in your notebook so that you have this formula when you go to do the assessment. You're going to want that formula. Okay, so let's look at a couple of examples. So for a given geometric sequence, the common ratio r is equal to a negative 2. Okay, so that's nice. It tells us r is a negative 2. If the seventh term, a sub 7, is equal to a negative 17, okay, so we're going to want that information. Find the value of the 11th term, a sub 11. Okay, if applicable, write your answer as a fraction. So let's go ahead and plug this into our formula. So a sub n is what we're looking for, really. So we're looking for a sub 11. That's what we want to know. And we know what a sub 7 is, so we're going to use that in our formula. And we know what r is. So r is going to be a negative 2. And then n minus m. So n is this number here, 11, minus m, which is the number that's located there. So 11 minus 7. And then we're going to go ahead, we don't know what a sub 11 is, that's what we're trying to find out, but we do know what a sub 7 is, so let's go ahead and plug that in. That is a negative 17. So it's just a matter of, in this case, just plugging the information in. Okay. Now 11 minus 7, that's negative 2 to the 4th. Now we know a negative 2 multiplied by itself 4 times is going to give me 16, positive 16, so a negative 17 times a positive 16, and that is going to give you, let's see, 272. And that's your answer for the 11th term is 272. The value of the 11th term is 272. Now sometimes this gets a little more complicated. You have to calculate R first. So let me do one of those examples for you real quick.